Okay, guys. Good evening. Welcome back. We will continue with our session. So today morning, guys, we had a day 8 session, and now at the evening time we have a day 9 session. Today is it's day 9 session, and the date is the same 18th of your October 2025, and the time is 6:10 p.m. IST. So, guys, in the morning class, we had understood about the file system. We had discussed about the inverted tree structure as well as what are the different directories which comes under the slash, right? That's what we had discussed, and we just started with the different types of files. This is are the different types of files, right? This is how we complete. I mean, sorry, we just started with that. So we'll continue from here itself, right? Types of files in day 9 session. So now guys, so whenever we create a file, we create a normal file by using these commands actually. So let me do one thing, let me log in. I think I already have a server which is up and running. Yes, I have to just log in. Try to copy the public IP. If you try to watch the previous video guys, the IP address would have been changed. Now you could see the IP address is different because I stopped the instance, I started the instance. Once you stop and start, you could see that the IP address will change. Watch the day 8 session where I log into the server by using some IP address and watch the day 9, you will make the difference. Okay, the IP address is changed. So I'll try to copy this public IP. I will go to my download folder where I have this putty. Try to give Ubuntu at the rate. Give the IP address of the server. Go to the connections. Expand the SSH. Go to the auth. Expand the auth. Go to the credentials. Click onto the browse. Try to locate the PPK file and then go to a session if you want and then say open. Accept it. Okay, guys, so we're logged into the machine. So what I was saying that you can create a file, normal file or regular file by the help of this commands. Touch command, VI, even echo command also can use it. Okay, so if I say echo double greater than sign and then specify something like a file one and say enter ls. Can you see there's a file one has been created, right? So there are various methods are there, but most often the people always use the touch command to create a file. So touch command is going to create a empty file. It's going to create a 0 byte size file. 0 byte size file. Now some people will ask what is the difference between touch command and the other commands with which you create a file. Okay. What happens that touch command basically what it does that it will update the timestamp. That is a small difference. Whereas the other command, if you created that, it doesn't do really change the, I mean, it doesn't really update the timestamp. Whereas touch command will be keep updating. So for example, you have created a file by name Alice file, right? By using touch command. So when did I did, if I do a stat command on say Alice, can you see here guys? It was created on 17th, that is yesterday it was created, and you could see that at some time based on this time zone, right? At certain times it was got created, right? Now, for example, if I try to run a touch command onto the same file, touch command on the same file, even though the file exists, I'm just giving touch again on the same file. Now, what happened? It will not create any new file. What it will do that it will just update the timestamp. When I do a touch Alice and again you execute the stat command, can you see it has updated the timestamp now? See, it is today's 18th, and it is based on the timing. If I execute the date command, can you see 12:43? It has updated with the same timestamp what it did. So what touch will do? Touch will only update the timestamp, right? If you do a touch onto the same file again, it'll update the existing timestamp. Whereas other commands, this commands, right, it will not update the timestamp. So unless and until you don't open that file, you don't do any editing of that file, until that time, it will not touch. It will not update the timestamp. This is the small difference between touch and the other command. Sometime in interview, they might ask you just to check your knowledge. What is the difference between touch and the other commands what you created? What does exact touch? Sir, touch will only create a file, sir. Okay. If you run a touch command onto the same file, what will happen? And nothing, sir. Nothing will happen. No, no. Think about it and tell me, man. What are the other things? What you have noticed? No, sir. I don't know. You will say like that. You have to say that no, sir. A touch will do an update to the existing timestamp. Whatever the timestamp is, it will update to the latest timestamp, which when you execute the touch command, right, it will update to the latest timestamp what is available in your current time and date. It will update it. That's all you have to say. Okay, fine. So now these are the three permissions, guys, for every file: access time, modified time, and change time. Access time is something like when was the file which was last accessed? When did the file which you last opened it? Whenever you do a cat command onto that file, right? When I say cat to that file, it will update that, okay, I accessed this file last time at that particular time. So this access time will get changed whenever you open a file. When was the file last modified? Suppose you open a file and you try to edit some content inside the file. You are deleting some line or adding some line. That is something called modification timestamp. Change time is something like where you are moving your file from one location to other location, or you're renaming the file from Alice to some other file. Then what happened? This change time will change. So basically for every file or a directory or any type of file, any type of the seven type of file, always what happened that these are the three timestamps you will have. And whenever you want to, how you can display this timestamps, guys, by executing the stat command. So this you should remember, guys. In many of some of the interviews, they have asked this also. Okay, I want to check the timestamp, man, or I want to check some other information like inode number. I want to check it, or I want to check the what is the user ID, group ID of that file. Is there any command to do it? Yeah, stat command will give all the statistical information about that file or a directory. Right? Similarly, you have a file by name folder like Raju or your directory. If you can even run a stat command on Raju. See, this will also show you the all the details about the Raju folder. So it could be folder, it could be a normal file, it could be a directory, it could be a soft link, it could be hard link, anything it could be. You can run a stat command onto all this type of file. Okay. Directory is something where you create a folder, right? So we use a mkdir command to create a folder or to create a directory. Right? So mkdir, so what happened when you create an mkdir, with the help of mkdir, we create a directory, right? It will create a directory. Like here, you saw that if you do an ls, you could see that there are so many directories are there. It's created. So let me one thing, let me take a mkdir. I will take some name in our group. Like for example, Mahesh is already created, Pankaj is there. I can create Naveen directory. Say for example, mkdir Naveen, I'll say enter. So can you see here Naveen folder has created. But when you're creating a Naveen folder, by default, that folder will have two links. Can you see if you execute a stat command on Naveen? Can you see there are two links, guys? So these two links are nothing but you can call it as a hard links. So each and every folder by default, it will have two minimum hard links actually. So if I go inside the Naveen directory, you can execute the cd command onto the Naveen directory and say ls. You would not see anything because it's an empty directory. Suppose if you do an ls-a and say enter. Can you see, guys, there is a dot and there's a double dot. If you want to increase the size, let me increase the font size, guys. If you want to it, okay, let me do this. Let me make it 18 so that it will be visible for all of you. Yeah. Now, can you see it when you do an ls-a? Can you see here? You are getting dots, one dot and double dot. Double dot, these two are links, we say. Every folder will have minimum two links. Okay. One is for itself. One is for the parent directory. For the Naveen, who is a parent directory? Ubuntu is a parent directory. For Ubuntu, who is a parent directory? Home is a parent directory. For home, who is a parent directory? Slash, like this. Every folder like this or every directory inside it has some two dots. One is a single dot and there's a double dot. Double dot, it's for itself. See, if I execute a command cd dot and say enter, it will not go anywhere. It is for itself. Whenever I want to go out from the directory, what I will do, I'll do a cd dot dot and say enter. See, you'll go out from that folder. So, right, when you do LSI, so where are you now? Under slash home Ubuntu. And under Ubuntu, so many other. If I do ls-a, okay, can you see these two dots? Yeah. Rajesh, you go to any folder, yeah, you'll get. Suppose you go to Ravi, you go to Naveen, you go to my, go to any folder and do ls-a, you'll get these two dots, dot, single dot and double dot. Double dot is for a parent directory, single dot it's for itself. That is what happened, guys. Whenever you run a stat command onto a directory like that, it will show that there are two links are there. Now, for example, assume that I will go with the Naveen directory only. Insert Naveen directory. Let me create one directory. Okay, something. I'll say mkdir Sharan. So under the Naveen directory, there is a Sharan. Come out from the Naveen directory, do a stat command, check how many links. Can you see there? It has created a third link because inside the Naveen, there's one folder has been created or directory, and it will maintain one link actually. That's what you would see that when you execute a stat on Naveen, it is increasing to one, and now it is totally showing as a three links. So whenever you are creating a file, or else for example, let me go to the Naveen directory again, and let me create one file, touch Babu something. Enter and say ls-a or ls. You could the folder Babu and Sharan is there. Okay, fine. Come out from the Naveen. and do a stat of Naveen. It is still there because only one directory, for the directory only it will make an entry. For normal files and all, it will not create any links. So these links for basically for the directories only. For a normal file, if you execute a stat of Alice, see it will only show the only one link only. That's all. Right, guys? Now, apart from all these things, guys, you can also see that it is showing you something as an inode number. This is what we call the inode number, or we can call it as an identification number. Okay. Inode stands for identification number, or we can even call it as the index number or index node. Now, in Linux, guys, whenever you try to create any file or a directory or any type of file, whatever the 7 types of files you have, whenever you try to create any of the 7 types of file, what the Linux kernel or the operating system will do is that it is going to allocate an inode for that file or for a directory or whatever type of file you are creating, right? It will try to allocate an inode for that. Inode is something like a identifier. It's a unique number assigned for each and every file or a directory. So why it is happening? Because that the kernel will do operation onto that file or a directory with the help of this inode only. So whenever a user, here this is a user space and below is a kernel space. Here what happened, the Ubuntu user sitting here and he is creating a files. So what the Ubuntu user did here, he executed a command, something known as a touch Alice, something touch Alice. As soon as you execute this command, what the kernel will do here, kernel is going to create that file Alice into that specific path, right? Kernel will try to create a file, and what the kernel will do, that kernel will try to allocate a inode for this Alice file. An inode will be allocated. So this inode, it is something like you can understand it as a data structure. It is, you can understand it as a data structure. This is like a data structure or something, a piece of code which is assigned to this Alice file. Now, what happened basically, guys, your file will be attached to an inode. It will be attached to an inode. It will be having a link towards an inode actually. And this inode has various information about this file. About this file. What are the information? It has information that who is the owner of the file. So Rajesh is the owner. So he's the owner. Okay, Rajesh is the owner. When was the file? When was the file created? Creation timestamp. Timestamp. When was the file? When was the file? When it was last accessed? Modification time. Change time. Pointer to the data blocks or addresses of the data blocks. Where inode also has information about the inode number. It has some other information like user ID, UID, group ID, GID, we call it as GID. All this information, guys, about the file is available. So whenever you create a file, a kernel has to allocate a inode for your file, inode for the file, and that inode will have all these informations. So inside inode, it maintains all this information. Who is the owner of the file? When was the file created? When was the file last modified? When was the file last changed? What's an inode number? What is user ID, group ID, pointer to the data blocks or addresses of the data blocks? See, when you create a file, obviously you'll try to write some text inside a file, right? Where are all those data are stored? Those data are stored into these data blocks. It is stored in a data blocks actually. This is called data. Something like this. Here there will be a lot of data blocks will be there like this. 1, 2, 3, 4. Assume that there are 4 data blocks which is assigned for the Alice file. Now somebody will try to open this file, a user, and he'll try typing some text inside the file or he'll start doing something. So automatically what happened, what the kernel will do, that it will try to write the data into this data blocks actually. Like this. Like this. So now what happened? Where are the actual file contents are stored, guys? Your file content or actual file data is actually stored inside these data blocks, we say. So in a file system, you take any file system, each and every file system has some blocks actually, has some blocks, but minimum blocks are, how many blocks are there minimum? There are 4 blocks are there like this. Think. 4 blocks are there, guys. What are those four blocks? Every file system has a four block. One we call as a super block, inode block, file block, and data block. Every file system, you take any file system, you take NTFS file system, that is Windows based file system, or else if you take a Linux based file system like ext file system, or you take a UFS file system, Unix file system, or you take HPFS, NFS, not NFS, Android file system, Coda file system, okay, HPFS file system, we call it a hierarchical priority based file system. You take any types of file system, every file system has certain blocks, and those blocks are called as a super block, inode block, file block, and data block, like that actually. So this is one of the data block where your actual file contents are stored. Super block is something where super block will have information about your entire file system. Because if I'm talking about the ext file system, which is the Linux based file system, this super block will have information about this ext file system itself. Suppose if I'm talking about the NTFS file system, that is Windows based file system, then NTFS file system super block will have information about the NTFS file system itself, like this. Right now, so super block is meant for keeping the information about the file system itself. We call it as a super block. Inode block is something where it will keep the information about the files or directories. When you create a files or directories in the file system, who will manage everything? The inode block will manage everything. File block, whenever you want to do operation onto the file, whenever you want to open a file, read the file, write the file, do the modification of the file, change the permission of the file, move that file from one directory to other directory, or rename the file. You do multiple operation, right? That means that you are trying to do some kind of a modification onto the file or directory. Who will manage all those modifications and all? Your file block will manage. And finally, the data block, where your actual file contents or file data is stored. It is stored in the data block section. Did you understood, guys? So can you Google it out very quickly? You go to that app. What is super block in the file system? See, what is super block? I know D entry file block. See, super block. I know D entry or D entry dentry. We say. We need not to learn all these things, guys, but they have given all this. Superblock is essentially a file system metadata, defines the file system type, size, status, blah, 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 so many things. You can get the information with the help of an FSCK, right? And you can run a dump E2FS command to do it actually, right? Dump E2FS will show all the file system information. Like for example, here, I'm just telling you, don't worry now, just see what I'm doing. If I do it fdisk-l, this is a command. Later I'll come to the picture. Don't worry. Can you see there is a something known as a uh, slash dev nvepm. Some number is there, right? EFI extended file system. Can you see there is something like this is the file? Yeah, this is the partition. Yeah, okay. Let me do one thing. Sudo dump e2fs slash dev nvmp, whatever the number is there. Okay, and do a pipe it to less like this. See guys, you got the file system information about the disk itself. See, what's an inode code, what is a block count, everything. Now, if you come, there is one magic number is a 0EX53. Where is that, sir? 0EX53. Can you see? This is the file system magic number of ext5 file system. And where it is mounted, it's a slash partition. If you come down, see, you will get the super block, group descriptor, okay, GDP blocks, block, inode block, and all the free blocks like this. See, you have a group 0, group 1, group 2, like this is a file system. I can elaborately explain, guys, but it is not required for us at this point of time. When I take a system level programming, I will discuss about all these things. I will have a separate session after January where I will be taking a complete Linux kernel internals. I will take a session free for everyone. Those who are interested, they can attend. All process management, memory management, file management, device management, network management, all in depth I will teach. Those who are good at C language, they can understand everything very well, all this file. I will try to take that class. It will be very lengthy class. I'll be taking the class who are interested in embedded systems. For them, I will take the class. So this is what dump E2FS. Like that, there are so many other commands. Dump E2FS, MK2 ETFS, MK2 MKFS, MK2 ETFS. Tune E2FS. See, tune E2FS. See, these are commands. Dump E2FS. Like that, there are many commands related to the file system itself. I will discuss that later, but right now it is not required. Now, what you understand that for every file system, sir, these are some free blocks. 4 blocks are there. Okay, fine. We understood something now. Now, coming back to here, when I create any file, what the kernel will do, kernel will allocate an inode from this inode block. It will take one inode and it will allocate that inode to that file Alice. And this inode in turn has all this information. Who is the owner of the file? When was the file created? When was the file last modified? When was the file last changed? What is the pointer to the data blocks or addresses of the data blocks? When a file contains, when you have a file and when you're storing the data, in which data blocks all the data are stored. Here there will be a lot of data blocks will be there. So somewhere in some data blocks, what happen? Your file contents, your actual file data will be stored. So it means that your inode is actually a pointer to your data blocks, or it will have a pointer or address of the data blocks. That's what I'm saying. Pointer to the data blocks or addresses of the data blocks will also be having a information within inode. And also it has an inode number also. Every inode is having a unique inode number, which is again, it is there within the inode itself. And it has a user ID and it has a group ID. All this information of your file system, what we call this information as metadata. What do you call, guys? We call it a metadata. Sometime in interview, they'll ask, what is metadata, man? In Linux only, you'll say, sir, whatever the information which is there inside the inode, what are the information where inside the inode it holds, right? That inside that inode, what are the information there? That we call as a metadata. It means that information about the file kept inside the inode, we call it as a metadata. Information about a file kept inside the inode, we call it as a metadata. And how do you display the inode number, man? Sir, no problem, sir. By using the stat command, we have seen that, right? We have seen that stat command, right? If you execute stat command and specify the file name, can you see that? It is displaying the inode number here. Okay, sir. Or else, is there any other option is there, Rajesh? Yes, sir. ls-i, inode number and specify the file name. See, can you see the same inode number? The same inode number will get displayed. Now, why we need an inode number? Because whenever the file is getting created, guys, the kernel doesn't understand any file with the name. It never understand what is Alice. For user, for us, okay, we understand a file with the name. But how the kernel understand? Kernel never understand with the file name. It understands with the number, and that is nothing but the inode number. So whenever the kernel want to do operation onto this file, whenever it want to open the file, write some data inside the file, read some data into the file, you want to delete the file, the kernel can do operation with the help of an inode number only. And that inode number is actually coming within an inode. Again, how the kernel is managing all these things, because that in kernel there are so many data structures are there. One of the data structure which the kernel manage for inode is something like a struct inode. Guys, you need not to learn all these things. I'm just telling you, struct inode is a structure. In this structure, what happened? It maintains all this information. Where the structure is there, Rajesh? See, /usr src linux include. Very fantastic, sir. This include. This and all, Rajesh, do you have to really learn, sir? No, sir, not required, sir. Please don't read. Don't, there's no need for this, right? Include, I'm just telling for information, Linux. See, PWD, this is a path, guys. Under this path, include Linux, there is a file known as a fs.h. Under this, can you search for struct inode? Oh, can you see this, guys? See, these are structure. These are all people who have a knowledge on C, C++, they will understand. This is what the structure for. It means that, Rajesh, is the structure is allocated for every file. Yes, sir. Internally, your kernel will allocate for every file, and inode is there. How the kernel manages inode with the help of this structure, struct inode, which is there in fs.s file. You know, this is the path actually. If you do a control F, not control F, control G, you will see that it is fs.h file. So, guys, did you understood something? I know that it is quite this one, but did you understood something?
Yes.
Yeah, whatever Krishna is saying is right. It's like a super block. Yeah, I will discuss all these things, sir, because super block, there are so many entries of the super block will be there in an alternative fashion. They manage it because super block will have the information about the file system information itself. Some block, if it get corrupted, what happened that there is an FSCK check program is there that checks and it will go to and it will repair that super block, and then it will try to copy information about the super block from copying from the other block actually, where it finds a valid information about the super block. All these are something very good concept, guys, which we have to know. But for a DevOps engineer, I'm saying that it is not that much required, right? It's all your passion. If you want to learn, you can learn deeper way. Okay, guys. One second. Okay. So now you understood about the inode. I wanted all of you to understand that inode concept. What is this inode? I think that we understood it now, right? Good, sir. Now going back here, so second is a directory, guys. It's a clear that we have created a directory, and whenever you create a directory, you know that there will be two hard links inside the directory. One is a dot and other is a double dot, right? Dot and double dot. Yeah, this is by default. Every directory will have these two dots, single dot and a double dot. Okay. Hard link. What do you mean by hard link? Very important, guys. In not in one interview, almost all interview, they will ask, oh, what is the difference between hard link and a soft link? This is a very common question. And everyone will know about this. They'll answer it aram se. But I'm just telling you. Now, what happened? I'm just telling you that you also try to understand what is the difference between hard link and a soft link, because we'll be using a lot in our day-to-day activity also, particularly soft link actually, not that much about hard link, but still we have to understand what is the difference between hard link and a soft link. But let me first try to tell what is hard link and hard link first. Now, hard link is something, guys, where we try to keep a copy of the same file. Suppose here what happened, right? I have an Alice file. You are writing some important program in that Alice file. You say that, Rajesh, I want to keep a copy of the same file. You can either use a copy command to keep it, but I don't want it. I want to keep a hard link of the same file somewhere. So what you can do, you can use an ln command, or else let me do cat of Ganesh. Okay, I have a high something. I want to keep a hard link of the Ganesh. Okay, so what I will do, I'll use an ln Ganesh. Okay, and I will just say something. What are the things, man? I'll take some name in our group. Okay. Uh, I can take Rajiv. I can take Krishna Sai, right? I'll just take Sai. So I want to keep a hard link of the same file. What I'll do, I'll just say ln Ganesh and then say Sai actually, and say enter. So if you do an ls, can you see Sai file has been created? Sai file is an hard link for the Ganesh file. Whenever you're doing any changes to the Ganesh file, the changes will also reflect in the Sai also. Whenever you are trying to remove some content in the file, Sai will also, content will be changed. So whenever you update any one file, the other will get reflected, right? If I do a cat of Ganesh, it has a high. If you do a cat of Sai, it'll also have the same thing. Suppose assume that I open the Ganesh file. Don't worry now, I'm just using a VA command to open that file. I will go here, insert mode. I'll just type some text inside the file and I'll save this file. So I did to the original file Ganesh, but if you do a cat of Ganesh, it will show me that changes. And if I do a cat of Sai, it will do the same changes. Because here what happened, guys, Sai is not a copy of that Ganesh file. Sai is another name of the same file. Right? It is not like a copy. It's like another name of the same file, because both these files are pointing to the same inode number. If I try to do a stat on Alice, sorry, on Ganesh, can you see the inode number, guys? 26232. When you do a stat of Sai, then you see it's the same inode number. Because it's the same inode number, both the files are pointing to the same file. If you're trying to do any one change to original, only one file, the other file will get reflected the same thing, because both the files are pointing to the same inode. So you cannot say it's a copy. If it is a copy, then what happens? The kernel will give a new inode for that copy, right? It's not a copy. It's another name of a same file, you have to say. Okay. So the first point is that actually for the hard link file, what happened, guys? ln command is used to create the hard link file. Create the hard link. So when you create a hard link, when hard link file is created, a new inode, no, not inode, inode is not allocated to the hard link file. To the hard link file. Okay, you can only create hard link file for normal files, not for directories. You cannot create a hard link for a directories. Only for normal files only you can create it. The third point is hard link cannot be created across partitions. We can only create a hard link within that same partition. Suppose there are two partitions are there, partition 1 and partition 2. And you're saying, Rajesh, I am having one file in partition 1. Can I create a hard link under the partition 2? No, hard link will not support because you need to create the hard link file under the same partition itself. You cannot have a hard link across partition. So opposite of hard link is soft link, guys. So what we do that soft link, for the soft link, what happened, right? ln with hyphen s command, hyphen s option command is used to create the soft link. When soft link, or we can call it as a symbolic link. Soft link, I can call it, or either call it a symbolic link. Anything you can say. Okay, when a soft link is created, a new inode is allocated to the soft link file. You can create soft link both for normal file as well as directory. Whereas there you cannot create a soft link for the directories, but here you can create. See, for example, if you have a Mahesh directory or anything, Raju directory, if I try to do an ln Raju directory, okay, to anything, Ravi is there, Raju is there. What are I think one more name? Can you give me Dipali? Right, Dipali is there, right? So you can create a hard link for a directory, guys. You cannot create. See, Raju is a directory. I'm trying to create a hard link for Raju as Dipali, but it will not allow because hard link can only be created for normal file, not for a directories. And right, whereas a soft link, you can create a both soft link for both normal file as well as a directory. Okay, you can create a soft link for both, for both, for both normal file as well as a directory. Okay, and the last point is that you can create the soft link across partitions. Whereas a hard link, you cannot create it. That's what. So these are the major differences you have to say in between the hard link and the soft link. These are the 4 points you have to tell in an interview. Okay, guys.
Sir, if we
Uh,
delete if you have
hmm.
created the hard link of Ganesh
Hmm.
file with the
Hmm.
name of Sai, if you delete the Sai, then the Ganesh will be also deleted, or
No, here what happened? Here you have two files, Ganesh and Sai. Ganesh, Sai is a hard link for the Ganesh, right? If I try
yes.
to remove the original file, Ganesh, okay, still you could see the Sai is there. Still you can recover the data. But if you try
Okay.
to create a soft link, like for example, let me remove the pop and I have an Alice file. Let me try to do some string echo hello all double greater than to Alice. I'm just trying to inject some text inside the file. We do a cat of Alice. So it has this thing. Now, if I want to create a soft link, I'll say ln-s Alice and Bob. Now, when you do an ls, say Bob is a pointer to the Alice. How do you maintain? If you do an ls-l, enter. Can you see? Bob is actually a pointer to the Alice file. It's a pointer, actually. So this pointer is not, it's a symbolic pointer to the Alice. It means that this Bob file, it is actually a pointer to the original file Alice only. Right? Now what happened when you do a stat of Bob? So stat means it will give you some inode number. This is the inode number of the Bob. When you do a stat for Alice, can you see the inode numbers are differing here? Yes, obviously the inode numbers are differing here. Right? The same inode is not there. It means that Rajesh, but if you update any one file, suppose if you try to do a echo, how are you? Double greater than Bob. See, when you do a cat of Bob, see, it has updated that. And when you do a cat of Alice, it has updated one. But if you remove the original file, Alice, you are losing this pointer. So if I try to do an rm Alice, when you do lsf and L, see, Bob is actually pointing to a file, but that file doesn't exist because you have removed it. So this is something like a pointer. So whenever Bob is pointing or it is pointing to an address of the file, if this pointer is like an address, when it's trying to point to the file which doesn't exist, then this pointer will be pointing to address which that point with that address doesn't exist at all. This we called as a dangling pointer. So you point to some address, but that address doesn't exist. It will become a dangling pointer. So now what happened, right? You will not be able to. So when you do a cat of file, nothing is there. It will not show anything. It knows it for a directory. It doesn't even consider that as a file load also. So that's what if
So,
you say,
sir,
yeah, if you do ls, can you see here? It is showing as a red color, something like this. Yeah.
sir, for the inode which was created for the Bob, so
Hmm.
it will be deleted automatically or some garbage
Yeah,
collector
yeah,
will be
yeah,
run.
yeah, yeah. If you do a stat of Bob, it will not consider it. See here, it is still showing you that actually that there is a file exists with this. But what happened? See, I will tell you, man. Now, for example, let me do from the very beginning. Sorry, Bob. So what I did, like I created a file echo hello all to double greater than Alice file. So Alice file got created, right? Alice has this content, right? Now, when I try to do an ls hyphen s, okay, I will try to create some file, something like Manju. I'm just saying Manju, okay. Okay, original file is Alice, soft link file is Manju. I'm just saying enter. And when you do an ls hyphen l, so can you see here, Manju is a soft link for the Alice file, but Manju itself is an inode. It has to keep some information, right? What it is keeping here, it is actually keeping the file name itself, ALICE. These 5 characters are numbered 5 bytes. That information about the 5 bytes is actually holded by your Manju. That's what you could see that it is only consuming 5 bytes. Here earlier also, Bob was also what happened? It was having the number of characters of the file name, that is Alice in that Bob actually. It's showing file like this. Or else, for example, one more file I'll say, John or Joe. I'll say Joe. Okay, I'll just say ls hyphen l Joe to Bo, BOE, Bo. Now when you do ls hyphen l, can you see that? Bo is pointer to Joe, but what Bob is pointing, Bob is having a content of this file name or how many characters? Three. See, it is showing three. Now it is actually pointer. That's what it means that when whoever is accessing this file, Bob, actually is actually reading the content from this file only. Because when you're trying to access this inode, trying to access this file, Bob, actually you're reading the content of the inode itself, right? The Bob's inode, Bo's inode, right? But the Bob inode will have a pointer to the Joe file, where the Joe file exists. So you'll try to read it that only. If you are trying to remove this original file, if you try to remove this original file Joey, then that Bo is pointing to some a file, but that file doesn't exist at all. Then it becomes a dangling pointer.
Sir, I have a question.
Hmm.
So, for example, if this in the soft link procedure, we can see the pointer, right? Because, like for example, in this bow is pointing to the Joe. So, can you do the ls where you have all the files and directories? Um,
Hmm.
it's changing now. So, when you made the hard link file, I saw that the hard link file was colored as green,
No, 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 black only. No, 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 no.
right?
Now, yeah, yeah. Now Bob, Alice is there. If you do an ln of Alice Bob, so ln means hard link I'm creating, right? When you do ls, see Bob file has got created. Bob is also black color only. Whichever color is there, no, it will create that color only.
So, which one is the? I'm sorry, I forgot. Which one was the hard file in hard link in this?
In this, you cannot distinguish because both the files are pointing to the same file. While creating, you know that okay, Rajesh, Alice is the original
No,
file.
no, 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 sir, not this one. I mean, if you create a hard link,
Hmm.
if you create a hard link of, let's say, Ravi,
Hmm.
can you create the hard link of Ravi?
Ravi, where is Ravi is a folder directory. You cannot create a hard link for the folder. Only for
Ah,
normal
yeah.
file only you can create.
Okay, let's create it for maybe Alice.
Yeah, Alice we created. Okay, we can create one more man. Alice, yeah, what do you say?
Yeah, I
Pankaj.
mean anything. Yeah, yeah. And Pankaj is up.
Hmm.
And if you do Alice, okay, okay, it's okay. I think I
So
misread
Alice
it.
also has the same content. Pankaj also has the same content. If you remove the Alice file, rm is a command to remove the file. And you do Alice file, still Pankaj exists, no? Still, even Bob also exists. Even Bob also has the same content, no? Because all
Hmm.
these files are pointing to the same file. It means that all these files are having the same inode number. If you do a ls hyphen I, Bob and a Pankaj, you could see it is having the same inode number.
And sir, one more thing, like when, like for example, if you want to check which is soft link, hard link. For soft links, we can see
Hmm.
we have a pointer.
Hmm.
So if we open for example, we are in under the Ubuntu user right now.
Hmm.
So how would we just identify by just looking at the files and the directories, which are
See,
the hard
first, yeah, yeah. Hard link we cannot distinguish. That's what I said. While creating, you know that okay, Alice is the original file, Pankaj is above. So Pankaj is a hard link file. But what happened? No, you cannot see. It's like another copy of a same file actually.
Okay.
Another name of a same file. So it means that you cannot really distinguish later, but this is a hard link. So, but usually in industry, how they do it, man, to make it very much differentiated, how they do means actually in the real time. See, I have a Bob actually, right? For the Bob, I want to create an hard link file. What they do, no, they'll just say ln, they'll say Bob, and they'll just create a hard link with a dot actually. Dot is a hidden file, right? When you do an enter and say ls, see Alice is not shown at all. When you do a ls-a, now Alice would be shown. Where you see dot Alice. So what happened now? They'll hide that file, but they'll keep a copy of the files because mistakenly tomorrow, suppose I remove this file, somebody engineer came and he removed the file. Oh man, I removed it, but I remember that I had created a hard link for this file. Oh, I can recover back that file. Oh, what I'll do? Okay, man, no problem. I will copy the Alice again back to Bob like this, and then like I can see the content of the Bob. Did you understand?
Yes, sir. Yes. Okay.
So we'll always keep the hard link as a hidden by adding in front, we are adding a dot. Always whenever any file will start with a dot, means it's a hidden file or it's a hidden directory like that. Suppose here I have a Pankaj. Let me remove the Pankaj. I'll remove the Pankaj. I'll do a mkdir dot Pankaj. When you do an ls, it will not show here. But I want to display all the files. I'll do ls-a. A means all. Now here you could see that dot Pankaj folder is there. So any file or any type of file, if it starts a dot, it's a hidden file or it's a hidden directory, something like that. So guys, I hope that you understood these two types of files, soft link and a hard link. We understood it actually. And same thing, whatever I'm saying, you have to tell in the interview also. Same thing, right? There's no cross question. But sometime in interview they'll ask why we have this soft link span. Then what is the use of the soft link? Is like a shortcut. Suppose you said, Rajesh, I'm having a file with so lengthy like this /usr src Linux, whatever the Linux, AWS, include Linux. So I want to access this file by name, which is that file fs.sh or file.sh. Why you have to go to this path, complete path until end of that file and then access it? Can I keep a shortcut of this file in my desktop itself or in my home directory itself? Yes, sir, you can keep it actually. You can create a soft link, right? So ln-s file.h, right, or fs.h. What I can do, I can create under home directory Ubuntu, okay, as fs.h, same file. See, if I do pwd, I'm under home, right? If you do an ls, can you see fs.h is there? See, so fs.h is nothing but it is soft link to this file actually. Like that, what happened? You can create a soft link for that file actually like that. Am I clear, sir? So with this, what happened, right? You can keep a shortcut of it. That is one thing to easily access it. And one more important point, what you have is that I don't know how many people will do a lot of build activity when you're working as a DevOps engineer. We'll do a lot of build activity. What is build activity and all? We will discuss it later. So in the build activity, what happened, right? Like I'm just trying to tell you. I mean, I'm not sure how many people will try to understand this. But in case of uh, in case of when you're building activity, what happened, right? We build the commands also, but all the commands, what they do, right? They will try to create a soft link for that file. So what they do that in Linux, we build something like a busy box. Busy box is actually a collection of some important commands, right? So what happened, right? This busy box you build it. This is something like an executable, but this has all the content. Now what happened, right? What they do means actually basically they will have an ls command, they'll have a date command, they'll have a pwd command, they'll have a who command, they will have a command like an ln command, they'll have a command known as an mkdir command. Something you'll have lot of commands like this in the real world. What they do know, they will all these files will be a soft link to the busy box only like this. So that's what at the very initial stage I told you that I don't know how many people will understand this. So what happened, right? For the user, it becomes very easy to manage this busy box because all these comments, what I'm executing, actually it is a pointer to your some busy box only. So what I would say that just go to the article, what is busy box in Linux. So you will get to know about, guys, what is this busy box. This busy box is something like where you have a pointer. Okay, don't give the size and all. See, it's like a busy box. I will tell in some other context, guys, what is busy box. But try to understand that if you execute the busy box will have a pointer to many of the commands actually. So all these commands and everything will be pointed to the busy box only. This command busy box, the busy box, right? It has a collection of all these commands. Right now, for example, if I execute the ls command, ls is getting executed. But if I say where is ls, see, ls is actually a pointer. Ls is placed here. When I do an ls-l /usr bin ls, see, it is a command. It means that this command is there under this path only. For example, if I go to the usr bin directory, just observe. See, these are all the soft link, soft links, soft link. If you say that, Rajesh, there is a Python 3 is there. It is a soft link file. Now when I do a where is okay, LSF and L Python 3. See, it is a soft link to the Python 3 1.2. Where is Python 3? It's the same path only. If you see it, actually, it'll be having the same path only. If you do a Python, what is it? Python 3.1.2. Where is that file, sir? Python 3.1.2. See, can you see Python? See, can you see here? So this Python 3, whatever the Python 3 is, it is a pointer. This is a pointer to the Python 3 1.2 only. Similarly, gpasswd will be pointed to some gpasswd project. Like for example, if I do lsfnl gpasswd, see, uh, shit. Oh, it is some special file. That's what. Okay, something whatever you are saying. Any command you take, man. Like if you take a pkill command, pkill be a soft link to something actually. See, it is pointing to the pgrep. So when we are executing pkill, actually internet is calling the pgrep command only. When I'm calling a Python 3, it is actually internally calling Python 3.1, 3.12 command only. Like that it is called. So always what happened, right? You will be having like multiple soft link to the same file that happens in this busy box section. So busy box will be one big executable, but it has all the commands within it. Ls date command. Whenever user want to execute, he can call this command. That call internally will be pointed to busy box only. So busy box will take it and busy box will execute so that ls output you'll get it. Same thing you're executing date command. Busy box will be called, and that busy box based on the command execution, or it understand the user wants the current time and date. So this busy box will execute the date command part actually. So like this busy box is very much useful. Like when you are building some complex projects and all, right, you will try to create one executable file, but that intern has many commands in it actually, like that. Why we are doing all these busy boxes? To customize it. I don't want to have so many commands, man. With one executable, I can manage to do multiple operations. Then they try to build the busy box. This all happens in the build process, I'm saying. When you're trying to do a build, right? For example, when you're trying to build something as a Yacto project, there's a Yacto build project is there. Yacto build project. I am not sure how many knows up build system, Yacto build system. There and all, you will build all those busy boxes also here. So here you can't get all this information, but when you try to work on these projects, right, you will know that actually how this build system works and how these busy boxes are getting created and how all these commands will be a soft link to these busy boxes, right? So that is very important also. So you can give this one example if any interviewer will ask you. Like you can just say that no, why we have this? Nobody ask actually. First of all, if suppose somebody want to ask you very intelligent question like this, no, you can give this example so that he will get to know. Okay, this fellow knows something actually like that. Fine, guys. Okay, guys. Let us quickly go to the other things. Okay, pipe file. Basically, pipe file we call as a FIFO files. Basically, pipe files are used for having intercommunication between two processes or commands like anything. And in Linux, actually, in shortcut in our keyboard, we have this pipe symbol like this. You have pipe symbol, right? So this pipe symbol, when we use, actually internet is using this FIFO file or it calls a pipe file only. So we can create this file with the help of a mk FIFO command. So here, what happened if you go to the system and let me remove all this files. Just I'll just say rm-f. I'll come with this command later. Rm with the rf, okay, recursively and forcibly. We say r means recursive, f means forcibly. You are removing everything that is star. Enter. When you do an ls, you could see that all files or data you are removed it. Now I want to create this FIFO file. I use a sudo command mk FIFO, and again I'll just say my FIFO. Enter. Can you see a FIFO file is got created? ls, yeah. If you execute a file command and my FIFO, it says that it is a named pipe or it's a FIFO file. So this FIFO file can be used for inter-process communication like that. For example, this is one terminal. Let me duplicate the terminal, open the terminal, log in it. This is the other different terminal. How do you distinguish, guys? If I execute pty, this is /dev/pts1, or this is one terminal. If I execute this command here, what you'll get /dev. So /dev/pts/1. This is second terminal. So these are two different terminals. Now, if I try to want to do an intercommunication between these two, so what you will do basically, you try to do an echo, hello. Don't worry about all these things, greater than sign, and just say my FIFO. You're trying to write some text inside this my FIFO file. You have to use the sudo command. Okay. We cannot do it, guys. I have to switch to the root user. So later I'll tell you what is the switch and all. Okay. I'll go to the /home Ubuntu, run the same command here. See, you have written some text inside the file to this my FIFO. If you come to the other terminal, switch to the root user, go back to the same /home Ubuntu, and you can do a sudo of cat of double less than my FIFO. See, what I did, man, echo here. Here I just say cat of, oh, come on. You're reading the data like this. So in one terminal, you're writing inside this FIFO file, and in the other terminal, you're reading it like this. So it means that you're doing an inter-process communication with two different processes running the two different terminals. This is how the pipe symbol we use it actually. Pipes we use it. So here the my FIFO, guys, we don't literally use in our real time that much, but this is one of the type of file you have. And if you say just say type and the file name, sorry, type and say my FIFO. Yeah. File space my FIFO. So it will say that it's a FIFO file. Or else if you do an ls-l long listing, you could see that the first character starts with a P. It means that it's a pipe file. So here what happened, when you're doing an interprocess communication, two different process or commands in the same machine, then what happened, right? You can use the FIFO file. Suppose if you're doing the interprocess communication between doing an interprocess communication between two processes which are there in two different machine, then we use socket file. So socket file is used for doing interprocess communication between two different processes which are there over the network in two different machine. So socket, we call it as a socket programming, or you could just call it as a socket. Okay, with help of a socket only, you can able to communicate. So how this internally in the back end, how this SSH try to log into that machine, or else whenever you want to copy the data, you want to do something like an rsync command, right? You want to do an SCP command. You will be doing so many commands like rsync, SCP, SSH, telnet and all. How all this communication protocol works because there is a socket behind. The socket is something like one of the special file system. Using that, you can create a socket file. With help of a socket file, you can communicate from one machine to other machine or between one process to other process which are running in these two different machine. So over the network, what happened whenever there's a client and whenever there's a server, whenever both communication happens, they happens through the socket file only like this. So these are two different process. So these are two different machines which are there in the network. One is called as a client and other is called as a server. Assume that this client is something like a web client, web server, and this server, which is nothing but it is called as an application server. When these two processors or when these two machines, they want to communicate each other in a over a line actually, like this is the line, this is the communication line which they're having. When they want to communicate each other with this communication line, what happened in turn in the system or in the kernel level, what happened, right? A socket file will get created like this. There is a socket file here which will get created and there's a socket file which will get created. So this is something like which is just, we call this as a socket file. So here also you have a socket file. So both this machine can communicate each other with the help of a socket only. If there is no socket, you cannot make two machines to communicate each other. So whatever the network programming or whatever the networking stuff you do via everything with the socket only. So Rajesh, how the TCP intern works, how the UDP works, man. UDP, TCP protocol, ICMP protocol, ARP protocol, RARP protocol, RTSP protocol. You take any kind of network protocol, there has to be a socket. Like, right, there has to be socket, and with the help of a socket only the communication happen between one machine to other machine via with the help of a network. Then Rajesh, what about the IP address I heard? What about the port number? Yeah, man, those IP address port numbers are required to communicate, but before the communicate, before the IP address and before the port number, there has to be open socket. If there is no open socket, right, you cannot actually send a data from one machine to other machine. There has to be in socket. So Rajesh, does the TCP protocol, UDP protocol will try to open the socket while communicating? Yes, sir, they will try to open the socket. A file, socket file should be the socket has to be opened. With the help of a socket only, this machine can communicate to that machine with the help of an IP address and with the help of a port number through which they want to communicate each other. Am I clear, sir? Do you have any confusion, guys? Krishna?
No, no.
Nothing.
Good, sir. Good. Good. You have to at least open your mouth to say nothing, or else Rajesh understood. Then we are okay. I mean, I need somebody to speak, right? Otherwise, I'll be keep speaking like a robot only, right? Somebody has to respond to me, right? Anyway, that is fine. Okay, good. So this is a very, very basic level, guys. I'm saying very, very basic level. Networking first step means how do you communicate two different machines? Sir, there has to be some network. Okay, network is not there. How do you do it actually? There is no router, there's no switch. How do you do? Sir, there is a, coaxial cross cable will come, sir. We can connect to the cross cable and we can communicate each other. Okay, when you connect to the cross cable, how the system identifies the network? Yes, sir, there is something like a loopback address there through which it identifies. Okay, there's a network. Okay, how exactly the address, how exactly this machine will know that there is a networking, or this machine itself will understand there is networking, or there is a network stack is there in the system? Yes, sir, it understand only through the loopback address actually. Okay, so loopback address is something like this. If I say if config command, so this command is not there, it said command not found, you have to install this package, sudo apt install nettools. So first do a sudo apt update. So guys, now just watch it. Later I will discuss all these package manager commands. Okay, now just you watch what I'm doing. Sudo apt update, and then after that I will be installing sudo apt install nettools. So sudo apt install net hyphen tools, and I'll say hyphen y means yes. I will not give a, if I don't do it, it'll ask you whether you want to proceed or not. You'll say yes or no. So I don't want to do that. I want to directly install this package. That's what I use hyphen y option. So sudo apt install hyphen, see, it is installing this package. Once you install the package, you got that if config command. See, when I execute the if config command, it throwed me the error saying that this command not found, right? And it says that, okay, Rajesh, this command not found. And it is trying to say that, okay, you will get this command with the help of the installing this, this package, right? Like that you got it. See, if command not found, but you can install with the help of this, right? You got this command. Now, if you try to do an if config command, now you could see that, yeah, you got the network interface. This is one network interface and this is one network interface, guys. And this network interface where you see LO means loopback. Whenever you see loopback interface while executing this command, you can treat that, okay, your system has a networking stack. Networking stack is something like where your system has a capability to communicate to the outside world. But you cannot communicate with only with the loopback address, right? You cannot communicate with only with the loopback. You need to have some other external IP address, right, through which you can communicate, and that's the reason you have one more network interface. But this, by being loopback address, you can communicate internally within your own network. Suppose in your office, in the same floor, you have set up some 5 machines. You can communicate each other with one machine to other machine with the help of a loopback also, right? So loop back, but still what happened, we not communicate with the loop back. Again, what happened, we will create one interface and we'll assign some IP address into that some CID range, and then we will try to communicate each other from one machine to other machine. But I'm saying that the very, very basic concept about the networking is there or not. How do you verify or check? By checking whether the loop back is there or not, by executing the ifconfig command. If I execute ifconfig command, if I say LO, loop back means, oh, there is a networking stack enabled or available in my system. If this LO itself, LO means loopback address itself is not there, then there's no networking stack. Somebody has disabled the networking in your system. Simple. These are very, 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 very basic understanding about the networking, guys. How do you say in your system whether the networking is there or not? By just executing this ifconfig command, you will get to know. Some people who have disabled this, some would have enabled it, something and all they would have done, so that with that you will get to know, okay, networking is there or not in your system. Right? So there is one tool is there, command is there, ETH tool, etho tool is there. You can even say like this, you can go to the Google and you can just say ETH tool command in Linux here. Please dig this command, you'll get to know what this command does. So you are directly going to this command, query or control network drivers hardware setting. This is something you can make any of this loopback or any of these interfaces up or down with help of ETH tool command actually. Okay, I will discuss this when I come to the networking class where I'll be teaching a lot of networking commands and everything. There I will try to do this one, and also I will, they'll also, this one command is a link command is there. Link command is there. That also we will show you. Many commands are there, guys. Actually, if you get into the only a networking understanding only, there are lots of commands are there, plus a lot of concepts are there. Okay, we will discuss most of the things we will discuss in our upcoming sessions. Okay, fine. Now. Yeah, bonding concept. Yeah, that is network bonding, right? IP to IP bonding, right? We'll discuss even that also. Okay. Okay, fine, guys. Good. What are the other things are there, guys? Okay, coming back here to the notes. So socket is something. Okay, so we use this mksock command, guys. Right now we need to install the package. This somehow they have disabled this command. Right now this command is not there. But if you're working on RHL 7 or RHL 8, Red Hat Enterprise 8 or Red Hat Enterprise 7 or whichever version, right? You will see this command available over there. But in Ubuntu somewhere, this command they have disabled it actually. There's no command and there's no package also. I don't know what is the reason, but they have disabled this command. This is there in a Red Hat. It's there. Okay. Character device file, block device. This again is a special types of files, guys, where you can create a device files. Device files can be created. How do you create a file? By using the mknode command actually. So I'll go here. So let me do one thing, guys. Let me come out from this because I'm in the root user. So I have to exit out and I have to come out from this. And when you do an ls, nothing is there. So if you do a sudo mknode command, okay, I'll give a C as a character device file. Okay. Major number is 255, minor number is 10, and the file name is mycar. Enter. Oh, yeah. This is how you have created a character file. Same thing, you can create a block file. My block, say B, and 255 is a major number, 100 is a minor number. So can you see here? These are two files. So earlier what happened for the character device, I gave 250 major number, 10 minor number. Can you see my char 250 is a major number and 10 is a minor number. For the block device file, which is not but my block, 255 is a major number, 100 is a minor number. Can you see? Major and minor number. So these device files are represented with the help of a major and minor number. Okay, and this is the block device file. You could see that the entry is B, and this is a carrier device by seeing the entry C like this. You can see the first column or the first dash represents what type of file it is. Am I clear, sir? So these are all the different types of files, guys. I think you have understood all the 7 types of files. Okay. Nobody asked these questions, but it is good that you have this information in you within you, and it is good that if you get a chance to work on these different types of files in your life or in your project, it is good. But hardly I don't see any people working on these files, right? Only people who are working on embedded level, who are working on a system programming level, they will use all these files. Apart from the DevOps in like us and all, right, we don't use it. But keeping information is very, very important, because we know that Linux supports so many different types of files, 7 different types of files. What about in Windows, Rajesh? There are many different types of files are there in Windows. Even the Windows operating system manages, and it will try to keep it actually. Some of them are hidden, which we are not aware of, because when they release the manual, when they release it, they say, okay, this type of files can be only by created by the normal user. But there are rest other things are there which internally the Microsoft uses. We don't know actually, right? But whereas Linux is an open source, whatever you do with the Linux, it has to show you output, right? And with that, you will be able to understand, okay, these are the new things which are there in the Linux, right? By that, what happened when you are, when anything is an open source, guys, you will start exploring many, many things in that actually. So indirectly, you'll be learning a lot of concept with that tool or with that technology. Whereas a Microsoft, it's all a proprietary. They don't give any kind of information outside. So you have to just speculate about the things what they do it, or else you can be in touch with the top engineer from Microsoft. He will explain you what are the things which they are designing, which they are managing everything through the Microsoft Windows operating system. Otherwise, you will never get to know, because in the manual also they will not give much information about the Windows kernel level. They will not at all give any information at all. But whereas Linux, it's an open source. Anybody can go through the code, anybody can modify the code, anybody can put that code back to the modification state. So why they are doing everything as an open source? Because they want to increase the creativity of the open source, right? So why many tools and softwares are today still they are free level up, because it's not like they kept it out free, but what happened? They want the people to explore the things through the tool. Later, once you start working on the tool, tomorrow you might need more and more support from the tool. Then you will come for me to give the support. I will charge for you for all the support operation which I'll do. I'll also charge for the money which I will be, if suppose you want any kind of enhancement in an existing open source tools, you will come and ask me. I'm the maintainer, I'm the developer. Now I will say that, okay, man, this much you pay and take all the features, whatever you wanted. I will try to give the complete solution for you. So like that way, people earn from the open source also. Okay, guys. Okay. Now, suddenly many people exited. Fine, guys. What are the things you have? Okay. When we started the class, guys, 9:30, 10:30, 6, 7, 7:50. Is it fine till here, or should I continue?
Till here is good, sir. We can continue tomorrow. Or
Yeah, yeah. Because even I don't want to really, take up more. I thought to take 2 hours, but it'll be too much actually.
today is the
Right?
festival season in India, so
Yeah, yeah,
that's
yeah,
why
yeah.
lots of the
All are.
people are quitting.
Yeah,
Yeah.
yeah, correct, correct. So no worries. Sunday we can take tomorrow morning one class I will take, guys. Whoever are available, please attend. And Monday, Tuesday, and Wednesday, 3 days I won't take class because it's a festival season for all of us. So even including us, it's a festival season. We will not disturb anyone. From Thursday onwards, we will continue the class. So next class, that is tomorrow morning, Sunday, we will take at morning 9 a.m. Indian IST timing. But for us in Japan, it will be 12:30 p.m. afternoon. So for us, it is fine. So I'll try to take. So tomorrow what happened, we'll only concentrate on of lot of commands actually. So what are the upcoming things like commands we'll have to learn something around, I will be covering some 20 commands, not on the same day. And I will be covering on something on a shell, shell, bash features. Okay, like that I will go it. And also we will try to cover about the user management and about the permissions like that. User permissions or user management, sorry, file permissions, sorry, yeah, file permissions, right, right. That thing, and networking related commands, and networking concept. This also we'll try to cover in our all. These are the upcoming sessions, guys. Afterwards, we'll also see the Linux shell scripting. Okay, if required, we will talk something on the server level. Okay, what are the different servers we have? How do we manage and configure it? Right, all such things we will cover it. So, and finally, we will try to cover the interview question answers, Q&A, and also we will try to cover the one or two on troubleshooting sessions, basic troubleshooting sessions. Okay, so with this guys, we will be completing our Linux portion. Once the Linux is over, okay, earlier we had something discussed about the we'll take AWS or DevOps. Let me continue the DevOps only. We will start with the Git actually, and then we will go with the GitHub Actions. This is how our next upcoming agenda is. These are tools. So Git will take me around some 15 sessions to complete it. 2 weeks flat, 2 weeks, 15 sessions. And GitHub Actions, you can consider from between 10 to 12 sessions, or else max within 10 sessions, I'll try to complete the GitHub action. This is how our agenda would be, right? So next one month, we will be covering these topics only. Now almost 1 month or 40 days class we'll be covering. Okay. Thank you then, guys. Let me stop the recording. Let me stop the
Sir, one
recording.
thing I have to ask.
Hmm.
When you have run the stat command for any file, we were not getting the local time according to the Japan. How we can set the local time in any VM?
We can do the local command by using a date command only. Date
Okay,
command. Yeah,
date
date command you can,
-s.
yeah, -s, or else there's a command HW clock. HW clock is not there. You can install this package with HW clock, also can set the timing, Japan timing. You have
Actually,
to
we
see,
if we want to set the local timing according to our country, so how we can do on VM?
that's what you can just say that date command setting for Japan local time in Linux.
Okay, or we can
Hmm.
configure some NTP server or
Yeah, NTP server also can do, but NTP it's one second. See, NTP server is something, Rajiv bhai, where they manage it a separate server, right? In that server, what happened, right? They will configure all the date and time based on that. So whatever the servers which queries to the NTP server, you will do according to that local timing what is set in the NTP server. But in our local machine, I want to set it. I can even use the time date CTL command. You can set. You can go to that article. They have given all the commands and how to do it. We have to check. Japan is a what they use. They use something like JPC command or JPC. Here, what happened? You could see that it is a UTC time is there. If you see here, UTC time is there.
yeah,
So you need to,
UTC.
yeah, UTC check what is there, and you need to give the same format like this. And when you are seeing Japan timing will show you something. They might show it as a, here you could see that if you execute the date command, you could see that it's showing you the Saturday, October 18th, minutes, hour, minute, and this one UTC. And there we don't know the format. You have to see what is the JPC or the Japan format. In that only you have to set in a system. It will allow. It will make allow. Then you execute a date command. It will show the perfect date what is there in your system or whatever there in your clock. Right? It will show the same system time like this.
Okay.
So now you could see the time date CTL command is there. You have to just execute this command. You will get all
Mhm.
those time information. You have to go to the particular time zone. Yeah, this is what word I was missing, time zone. So if you go to the Japan time zone, you can synchronize, you can set all the things. Man.
Okay.
See, list the time zone. See, it list it out. See, you can even do a grep of the Japan, everything. It will show the format and then you can just follow this document.
Okay. 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 Okay.
You set timing and you could see that like this.
Okay. Set timing and we can. Okay. Set
Yeah.
the timing then.
Yeah.
And one more thing, sir, when you have created one file, so there was pointing out there is the two link file. There is the dot and double dot. So dot and double dot is the hard link or the soft link, means the.
Yeah, actually, what happened to the true sense, those are nothing but your hard links only. So
Okay, it is the hard link.
every directory has two links. One is a dot and the double dot. What are those? Those are a default links which is always there within a directory. Whenever you create any new directory, these two links are always available, and this is called as a hard link, not soft link.
This is the hard link.
Yeah.
Okay, where the metadata is stored or something.
Right.
Okay. Sir, and one more question. Suppose that in our organization, some the guest users come and we say that, okay, log in through this user ID, username, and we want to restrict them so that they can execute some particular command
Mm.
like the date command, like
Mm.
the who am I. So how we can
Mm.
do that in Linux?
So we can do that with the help of this,
PI
like
sudo.
sudo's command. Yeah, sudo's you can go pi sudo's or
User,
else
yeah,
sudo's list file you
we
can
can
go and you
restrict
can
that user to the
restrict.
particular.
Yeah, command
तेरे को
also.
बंद करने बोला है ना ये सब?
If that command, if the user, what, 1 second,
तो इसका
guys, please mute yourself. Yeah. So you can go and restrict any kind of a command with the sudo's list file actually.
Okay, in sudoers file we have to update that command
Yeah, with that,
what we
like
want
for
to
example,
execute.
Rajiv user can only execute the ls command, date command. He cannot execute the if config command. You can restrict like that.
Okay, so sir, if you want to show, if you can show this in one of the class, so it
Yeah,
will
yeah, I will
be
show. Anyhow, I have to show those things because when we are doing when you're doing a passwordless communication between two different servers, right? There, what happened? I will be showing all these things, whatever you're asking. User creation. Suppose you want to block certain user not to log into this machine at all, right? You can
Hmm.
even block it with the help of a sudo's list. Under the sudo's list, you can just make an entry of that, right? So that he will not be able to access that server at all. He will not be able to do an SSH also. Similarly, even though if we do SSH, he cannot do more than this operation. Like that, all those things we can do it actually.
Okay, okay, sir. Okay,
Mm.
okay, sir. Thank you.
Yeah, guys, one more thing I want to tell you. Most of the commands are there. Most of the commands are there. I have never used in my real life also, in my real project also. Like whatever I'm saying now for sudos and all, I have never did it. How I am able to remember all these things? By only taking classes actually. Many of the things which I'll be telling now, I have never ever used at all at my real work also. But still, how I remember because I've been continuously practicing, continuously taking classes, continuously try to remember everything and make a note of it so that I remember all these things. So why I said this point, because it's not only that you want to work, it's good that you work on the real time and try to learn everything, but it's also something like if you are having a continuous enthusiasm in learning the same thing again, what happened, your knowledge will get increased and that knowledge will be printed in your mind. So when you try to learn any concept, guys, try to at least try to put effort in learning 2 times. If when I start a Git, try to go through all the videos 2 times. It's very difficult, but when you try to go to the second time watching and trying to practice, right, it will increase your understanding. It will clarify all your doubts, what are the previous doubts you had, and you will get a lot of clarity in your mind. And also, it will allow you to, it will make your mind to explore more and more. That's what when you try to learn the same thing again, one, two, three times, right? It will increase your thirst in gaining more knowledge. So this is what the simple trick where people are doing it to learn things in a better by continuously updating themselves again the same topic. So why many people are very good at Kubernetes? It's not like they're working. They are again revisiting the same topic again. They're updating. They're doing a lot of practice in Kubernetes. That's what they become master in Kubernetes. So nobody can become master in Kubernetes or Docker in any other tool in one time. When you read it one time, you might just understand it. Okay, I understood how this tool works, but I want to get one level deeper. Means I have to redo the same thing again one more time. Right. The third time when you're redoing the same thing again. Now what happened? You're enjoying learning that thing. So you need to spend more time. If I try to cover 200 hours on DevOps to learn, right? You need to spend minimum 600 hours to understand, grasp all the concept very well. You will say, Rajesh, where we have 600? 600 is almost equal to 1 year, near to 1 year time. Yes, sir, that is what I'm saying. Please try to spend more time so that you will be closer to the topic. You understand all this concept very well. And also what happened, you will not forget. I need that point. You shouldn't forget. Yeah, interview when you're going, you'll recall all the things. But what happened when you go at the work, you should recall all the things what you learned. I need that one. You should not say, okay, man, I executed one time, but I don't remember. No. Oh, I have executed. I know what is an output I got. You should able to recall in such a way that you should be able to tell the answer clearly to the interviewer. That can only happen if you're practicing each and every tool one or twice. And it is best that you practice for the third time also. So you have seen some people have learned or they have put a lot of effort in learning Linux for many years together, right? You have seen that so a lot of system admin again. So many things they are doing repeatedly. They are doing learning, applying the knowledge. You will see that after 4 or 5 years they will become master in the Linux actually because they have done a lot of Linux admission activity. They know everything. They can even catch any kind of an issue if they are while troubleshooting it. So that kind of a knowledge is required by all of us actually. When we are going for interview, it means that you should be so much smart, so much expertise that whatever he asks, we should be able to answer to him answer to his questions actually. Is it fine, guys? Do you agree with this statement? Of course, it is not that easy. It's difficult, but we have to do it. So, guys, please give your 7 to 8 months of time in learning all these things. Put your soul, heart, everything by practicing, learning everything. Definitely, guys, after 7 to 8 months, you will see that you're going to shine like anything. So that is what I would ask, request. I know it's a challenging work, but slowly give half an hour, 1 hour time every day. Weekend, you give more time, more time. You learn, you will see one day you will become master in all these topics so that you will be able to start applying and you can fetch a job also. Okay, guys, with that, I'll stop the session. Thank you all. Let me stop the recording.
Thank you, sir.